I mentioned in class today that if you'd use the root or the ratio and you get rho is 1, you are so out of luck. And I'm going to show you why that is. I'm going to use the root and ratio on this and on this, and I'm going to show you that my rho here is 1 and my rho here is 1. So what that tells me is that if rho is equal to 1, my series could diverge or it could converge. I just won't know. So here's what happens. So like, let's say, okay, I'll use the root. Do it on this series, lim rho equals lim kth root of 1 over k. That's going to be equal to 1 over the limit. K goes to infinity, kth root k. In other words, the top gives me 1, the bottom is going to be this. We saw in class that this is 1. Okay, well, my series diverges. Okay, so now we'll do the rho for this one. For this convergent series, that converges since p is 2 greater than 1. Here p is 1, which is equal to 1. So that's how we get divergence. So here lim k goes to infinity, kth root 1 over k squared. I probably should have done the last one slower, so I'll do this one a little slower. So what this is saying is that this limit is equal to this limit. The top here gives me 1. That's what I have in the bottom. We saw in class that this limit is also 1, but I'll show you why. This is really equal to the limit k goes to infinity, the kth root of k squared. That's 1 over 1 squared, which is 1. In this series, by p series, I should mention that, this series converges by a p series with p is equal to 1. I'm sorry, p is equal to 2 greater than 1. Okay, so what happens if I take this lim and I get 1? I don't know if it's like this series or like this series. So it's inconclusive. I just have no idea. Okay, and similar things happen when I do the ratio test, and I'll show you what that is. So I do the ratio, and I'll use a different series, minus 1 over k to the 1/2. And this converges by AST. We did that in class on Tuesday, 16. And it converges conditionally, which we talked about since this series, p is equal to 1/2, less than or equal to 1, so that diverges. Okay, so I'm going to use the ratio on this. So my ratio a to the k plus 1 is is 1 over k plus 1 to the 1/2. AK is equal to 1 over k to the 1/2. So my ratio limit is this. K goes to infinity, 1 over k plus 1 to the 1/2 over 1 over k to the 1/2 when I take the absolute values. That's equal to limit k goes to infinity. That's what this is. Remember, that's k. 1 over k plus 1 to the 1/2 times k to the 1/2 over 1. Well, that's equal to the limit k goes to infinity. I can write this as k over k plus 1 to the 1/2. Okay. Now, what this is equal to inside, this is really going to be this limit. That 1/2 has nothing to do with the limit, so I can put it outside. That's the limit here is 1, so I get 1 to the 1/2, and I get 1. So what happens here is I get rho is equal to 1, and the series converges conditionally. So if rho is equal to 1 in these tests, I could get divergence. If rho is equal to 1 in these tests, I can get convergence as I did here, this one down here. If rho is equal to 1 as I did here, I can get conditional convergence. So basically anything can happen. I can get a divergent series if rho is equal to 1. I can get an absolutely convergent series if rho is equal to 1. This series converges absolutely. Or I can get a conditionally convergent series if rho is equal to 1. So if rho is 1, this is the moral. Anything can happen. So you need to use another test. And we'll see other examples of that.